let's do an example that should help folks with problems 13 and 17 on section 810. The directions say use the binomial series to find the Maclaurin series for the function f of x equals square root of the quantity 1 plus x cubed. So I know this is not exactly problems 13 or 17, but I'm pretty sure that once I show you how to do this problem, you should feel pretty confident that you can get your way through problems 13 and 17. So if you'd like a little more background to what I'm going to do here, then look at pages 637, where the book explains why the binomial theorem is the way it is. All it does is it uses the definition of a Maclaurin series, similar to the flashcard that I gave you, just where your C value is 0, on a general binomial of the form 1 plus x to the k power. And then it just shows how it came up with the rule. And then on page 638, at the bottom of the list of common power series, it actually gives the binomial theorem. So let's just kind of make that really clear. So the binomial theorem says, if you have something of the form 1 plus x to the k power, that its expansion is always of the form 1 plus kx plus k times k minus 1 x squared over 2 factorial plus k times k minus 1 times k minus 2 x cubed over 3 factorial, and so on. Okay, so for this example, if I'm trying to get the power series, which is this right side, for something of the form f of x equals the square root of the quantity 1 plus x cubed, the first thing I would do is let's get the power series for, and what I'm going to do is instead of x cubed, I'm just to have an x there for right now. So the square root of 1 plus x cubed, oops, I just said that I'm not going to have the cube there. Okay, the square root of 1 plus x, which is also known as 1 plus x to the 1/2. And by trimming it down, then what I have is something that actually looks like it fits this pattern, where my k value is 1/2. So in that case, then the square root of 1 plus x, according to this, would be this right side, just what you'd get if all the k values were 1/2. So what would that be? 1 plus 1/2 x plus, and just 1/2's in for all the k's. See, 1/2 minus 1 is negative 1/2. Let's see, and then 1/2 minus 2 is negative 3/2. And then I didn't have time. I had plenty of time, but I didn't have room to write the x to the 4th term. But if I had, you would have gotten and so on. Okay, so let's clean that up just a little bit. That would be 1 plus 1/2 x minus 1/8 x squared plus 1/16 x cubed minus, I think, 5 over 32 x to the 4th, and so on. Okay, well, that's what the Maclaurin series would have been for the square root of 1 plus x. So now we substitute. Okay, so what do I need to substitute in for x to get what we're really looking for? So I'm going to substitute x cubed for x. Okay, so what would I then have on the left side of this expression? I would have the square root of 1 plus x cubed. And on the right side, if I made the same exact swap, I would have something that looks like that. So after you simplify it, it would look something like that. And you're done. All right, my friends, I hope this example is helpful to you. Again, I know I didn't do exactly the problems 13 and 17, but I thought you'd be best off if I left you with those to practice on and just to feel a little more confident doing them by yourself. Hope this is helpful to you.